Hello students, this is Dhanakumar. Now I am going to discuss about binomial theorem. Okay, binomial theorem is one of the important concept in 11th standard, right? Now here in binomial theorem, what are the methods mainly important in JEE point of view? The first one is problems based on general term. Problems based on general term. Internally middle term, numerically greatest term, coefficient of some x power r, etc. some problems. Right? After that, next reminder questions. Reminder or units place digit in some number. Next, sum of series by using differentiation and by using integration problems also there. Okay, so and next power, actually binomial theorem basic formula is what? By 2 x plus a whole power n. Okay, actual formula is what? That is equal to expansion nc naught into first element is what? X power n. First I am writing, later I will explain, you see, plus nc1 into x power n minus 1 into a plus nc2 x power n minus 2 into a square plus so on ncr x power n minus r into a power r plus so on ncn x power 0 into a power n. Right, now here observe this one. This formula sorry, this formula is applicable to for all values of n? No, this formula applicable only for small n is positive integer, that is n is natural number. If n is natural number, then this formula applicable. And right, and in this expansion nc naught, complete this part is called one term, right? And this is one term, right? Now in every term you observe that one, nc naught, nc1, nc2, so on, ncr, so on, ncn. These are all called binomial coefficients. Binomial coefficient. And formula also you remember in this way. Here I am using that word, n is upper suffix, 0 is here lower suffix. Fine. So here expansion lower suffix starts with 0, ends with upper suffix. Fine. And next, here x plus a. Here x is first element, a is second element. So first in every term, first element power you write down difference, n minus 0, n minus 1, here n minus 2, here n minus r, here n minus n, 0. In every term, first element power you write down upper suffix minus lower suffix, right? Second element power write down whatever lower suffix is there, that value right here, 0, 0, 1, 1, 2, 2, r, n, n, right? And one more point, in every term, sum of powers of first and second elements is equal to n, index. Clear? Right. And one more important point, this is first term, second term. You observe that one, first term lower suffix 0, second term 1, third term 2, means third term number minus 1 is equal to lowest suffix, correct or not? So what about this term number? R plus 1, R plus 1. So R plus 1th term is equal to what? NCR into x power n minus r into a power r. This is called general term. This is called general term. Fine. And what about this term number n plus 1? So in this expansion, total how many terms are there? N plus 1 terms are there. Right. This is the general basic concept about the formula for x plus a whole power n, where n is positive integer. Suppose if n is negative integer, then at that time this formula not applicable. Then we'll go for one more formula. And n is rational number which is not an integer, then also this formula not applicable. Okay, right. So in binomial theorem, first important method is problems based on general term. And next, already I explained that one. What are that main important methods are there? Fine. Now one by one we'll see. Now let us coming to first problem. The number of rational terms in the expansion of this. Okay. Before that, one more small important point. When will we use this general term? Later I will explain this problem. Okay. See. Suppose find coefficient of x power 10 is there. X power 10, x power 20, x power r. At that time apply general term. Fine. Next, second one. Find coefficient of x power 0. X power 0 means what? Constant. Means the term independent of x. So find the coefficient of x power some r, or find the term independent of x. Then also use general term formula. Fine. Next, third one. Find, suppose for example 20th term. Find 20th term, 30th term, 70th term. Then also use general term formula. Fine. Next, middle term. Middle term questions are there. Then also use general term. Fifth one. Find numerically greatest term. Then also use general term. Next, number of rational terms. Then also use general term form. These are the main important models in this concept. Clear? Now coming to this question. Here calculate what? Number of rational terms in this expansion. Right? Here two models, actually three models are there. What are the three models? First, calculate number of rational terms. Second one, number of irrational terms. Third one, sum of rational terms. These are the three models in this concept. Okay. So first using rational terms, how to find out this one. Later I will explain that how to find irrational. Anyhow, here question no need, but I will explain that how to find number of irrational terms also. Okay. Right. Here in this question, two methods are there. One general procedure, second one formula also is there. I will explain both. So let us coming to first general procedure. That is, number of rational terms questions are there. You have to use general term formula. Clear? Now general term formula I am writing. TR plus 1 is equal to, what is that general term formula? NCR, that is here power 124. 124 CR into what I told, first element power difference. First element is what here? Root 3. Root 3 power 124 minus R into second element. What is that second element here? Fourth root 5. Second element power lowest suffix. Okay, so that is equal to, simplification you see, 124 CR into root 3 means 3 power 1 by 2. So this can be written as 3 power 124 minus R by 2 into here 5 power R by 4. Okay, right. Anyhow, observe this one, rational term. When we say that complete this term is rational, that is our important point. Anyhow, 124 CR is rational number. Fine. Next, complete term is rational only when this power and this power value must be integer. Is it correct or not? Right. So let us coming to one order. See, first I am taking this one. When we say that complete this part is rational, when R by 4 must be integer. R by 4 is must be integer. When we say that R by 4 integer, when R must be multiple of 4, because denominator 4 is there. If R is multiple of 4, then R by 4 is integer. Understood? Right. So possibilities I am writing. R must be integer and R value always greater than or equal to 0 only. Right. So R value possibilities I am writing here. R values here. R possibilities write down starts with 0. R is equal to 0 if you are writing. Then 0 by 4 is 0. 5 power 0 means 1. It is rational. Correct? Then next 4 multiples. 4 ones are 4. So if you are taking R is equal to 4. 4 by 4 1 in your rational number. So 4 multiples. That's why I told 4 multiples. Here 4. 4 2s are 8. 4 3s are 12. So on up to 124. 124 is multiple of 4 or not? Right, multiple of 4. Okay, right. So for all these values, R by 4 is integer. If R by 4 integer means 5 power R by 4 is what? Obviously integer only. So integer means rational only. Let us coming to this one. When we say that this answer is rational, when power must be integer. Okay. So when we say that this circle is integer, when numerator must be multiple of 2. Okay. So here also R is there. Here R means just you verify for these values only. Then only at a time these two answers will be rational terms. Okay, don't take some other numbers also. For these values only you have to cross check it, right? Suppose if you are taking R is equal to 0, then what will happen? Anyhow, simple logic, 0, 4, 8, 12, these are all even numbers only. Correct or not? Right. 124 also even number. Even minus even, even. Even number always divisible by 2. Is it correct or not? Right. So for all these values, this circle value also what? Integer. Integer means This part is rational. So this part rational means what? Complete box is rational term. Right? So what are the possibilities are there here? 0, 4, 8, 12, so on 124. Total how many are there? See here, 4 means 4 into 1. 8 means 4 into 2. Correct now? 124 means 4 into 31. So from here onwards, total 31 terms are there. Plus one more term is there. Total 31 plus 1, 32. Therefore, number of rational terms. Rational terms. Total how many terms? 32 terms are there. This is the general procedure. Suppose calculate irrational terms. Number of irrational terms. In general, for example, in a class 100 students are there. Out of 100, 80 students passed in one exam. Right? Failure strength how much? How to find? In general, failure is strength is equal to total minus passed strength. Correct or not? In the same way, number of irrational terms is equal to total number of terms minus rational terms. Correct or not? Right. So the number of terms is equal to what I told now, power plus 1, that is 124 plus 1, 125, minus number of rational terms, then it gives number of irrational terms. That is the procedure for calculating number of irrational. Anyhow, our question are rational only. So total how many rational terms are there? 32. So second option is correct. Okay, this is the general procedure. Then what about another one? Direct to one formula is there. What about that formula? First you see, I am writing formula. Suppose the number of rational terms in, suppose a power 1 by some L plus b power 1 by some k whole power n. Okay, the number of rational terms in this expansion is equal to is number of rational terms. Formula is step of n by LCM of denominator values L comma K. This is what? Step function. And this formula will be used only when L and K. So here n is what? Okay, n is what? Index. When none of L and K is a factor of n. When none of L and K is a factor of n, then only you use this formula. Otherwise, step of n by LCM of L comma K plus 1. Okay. When will we use this plus 1 part? When at least one of L comma K is factor of n. Okay. At that time factor is there. At that time you write plus 1. Otherwise none of them is a factor of n. Then use first formula. Okay. Let us coming to our question. What about our question? Root 3 plus 4th root 5. Root 3 plus 4th root 5. Okay, fine. Root 3 means what? 3 power 1 by 2. 4th root 5 means 5 power 1 by 4. Whole power how much? 124. Okay, right. Now you observe this one. 4 is a factor of this one. Correct or not? Right. Understood? So when at least one of these two is a factor of n, then you have to use second formula. Fine. So using second formula, you observe this one. Step of 124 by LCM of 2 comma 4 plus 1. LCM of 2 comma 4 is what? 4. So 124 by 4 is what? 31. Step of 31 is 31. 31 plus 1, 32. Even using general procedure also we got 32 only. Okay. If you know this formula, this is very easy. Otherwise you go for first method only. Understood? Right. Let us coming to next problem. The coefficient of x power 24 in this expansion. First of all, you observe this one. Here number of here in base you observe that one total infinite terms are there. So at that time x plus a whole power plus n is natural number. That formula not possible. Right? First important point. Before solving this question, let us see first one more formula. After that we'll see that question. Clear? What is that formula? Just you see here 1 minus x formula I am writing whole power minus n, where here mod x less than 1 comma small n is natural number. Okay, small n natural number means what? Power negative integer. Power negative integer means first basic formula not applicable. Understood? Right. So this formula is equal to, okay, expansion you see here 1 minus x whole power minus n formula. Here base minus power also minus. Both are same signs. Both are same signs means in expansion contains all are positive terms. Okay, right, positive signs you write. That formula is 1 plus nc1 into x. First two terms only you remember. After that very easy. Next term will be just simply add 1 to upper and lower suffix. Clear? So that is n plus 1 c2 x power. X power value lower suffix same. Here 2 is there, 2. Can you guess that next term? Right, next term is n plus 2 c3 into x cube. Next term n plus 3 c4 x power 4. Okay, and plus so on. Okay, right, this is the formula for what? 1 minus x whole power minus n, and also this formula applicable only for two conditions. What are that conditions? Mod x less than 1 and small n is natural number. These two conditions satisfies, then only this formula applicable. Okay, fine. Now let us coming to this problem. Here 1 plus 3x plus 6x square plus 10x cube base is there like this. Right, now let us see here. Suppose if you are taking n is equal to 3, what will happen? You observe this one. 1 minus x whole power minus 3. So in this formula put n is equal to 3. Then answer will be what? 1 plus 3c1. 3c1 is 3 plus 3 plus 1 4. 4c2. Just you see rough calculation. 4c2 value will be 4 into 3 by 2. 2 2s are. So that is 6. 6x square plus 3 plus 2 5. 5c3. 5c3 is equal to what? 10. 10x cube plus so on. Now you observe this one. In given question, base value and right hand side both are same. Correct or not? Right, both are same. So in given problem, in place of base I am writing this left hand side part. Okay, So that question reduces to like this: 1 minus x power minus 3 whole power 2 by 3. So that is equal to what? Here simplification 3 cancel. So that is equal to 1 minus x whole power minus 2. Okay, right. Now easy. Actual question: calculate coefficient of x power 24. Right. See that next slide. 1 minus x power minus 2. I am expanding this one. Once again use this formula only. Okay. 1 plus 2c1x plus what I told, add 1 to upper and lower suffix. So 2 plus 1 3, 1 plus 1 2, 3c2 x square. Next term 3 plus 1 4c3 x cube plus so on. Correct now? Right. Now coefficient of x power 24. Coefficient of x power 24 is equal to, just you see here, no need to write up to x power 24. Simple logic, you observe this one. Here in this term x power value lower suffix is same. Every term, not only this, every term x power lower suffix is same. So here x power how much? 24. Lower suffix also 24. Upper suffix, you observe this one. Lower suffix 3 means here 4. 3 plus 1. 2 plus 1. 1 plus 1. Correct now? So automatically this value will be 24 plus 1. 25. So coefficient of x power 24 is equal to what? 25c 24. So that is equal to 25 simplification. NCR can be written as NCN minus R. 25 minus 24, 1. 25C1 value is what? 25 1. So given question answer is 25. So third option correct. Okay, right. Let us coming to next one more question. Little bit logical question. You see, 404 C4 minus 303 C4 into 4C1, 202 C4 into 4C2, 101 C4 into 4C3. Just you observe that question, right? Second term 4C1, 4C2, 4C3. Here for our convenience this can be written as into 1. Any problem? Right. In place of 1, 4C4 I am writing. In place of 1, 4C not. Sorry. In place of 1 I am writing 4C not because same order. Right. So observe this one question. 404 C4 into 1. 1 means I am writing 4C not. Okay. Right. Minus next term as it is 303 C4 into 4C1. Next term 202 C4 into 4C2. Next term plus minus plus 202. Next minus 101 C4 into 4C3. Here for our convenience into 4C3. So next term here alternate sign. So 4 plus 4C4. Any problem? Into, okay, 4C4 value is what? 1. So for our convenience minus 1 I am writing. Any problem this one? Some adjustment I wrote like this, plus 4C4 minus 1. Why I am writing like this? 4C3 is there. After that next term 4C4. So that is why add and subtract 4C4 part. See, In every term, first part, first element, lower suffix is same. 4, 4, 4. Is it correct or not? Right. So this can be written as coefficient of x power 4 in coefficient of x power 4 in this part is only for this part 404 C4 can be written as 1 plus x whole power, upper suffix is 404. So 404. Okay. So just you observe this one. Coefficient of x power 4 in this expression is what? 404 C4. Is it correct or not? Right. So next element 4C0 as it is I am writing into 4C0. Fine. Let us come into this one. Okay. Anyhow, lower suffix x power same. Just now explained. And here upper suffix how much? 303. So this can be written as 1 plus x whole power 303 into 4C1 as it is. Fine. Next, plus 202 na. So this can be written as 1 plus x whole power 202. Fine. 202 into 4C2 as it is minus. This part can be written as what? This part over, and this part can be written as 1 plus x whole power 101 into 4C3 remaining 2 as it is plus 4C4 minus 1. Understood my point? Coefficient of x power 4 in this expansion will be what? 202 C x power value and lower suffix same. 202 C4. Here 101 C4. Satisfies or not? Satisfies. Right. For our convenience, just you observe this one. I am assuming this one like this. 1 plus x whole power 101 is equal to some y I am assuming. Okay. Automatically this equation will reduces to like this. 4C0 into this part will be what? Y power 4. Is it correct or not? Is it correct or not? Just you see here I am writing rough calculation. Y power 4 is equal to 1 plus x whole power 101 whole power 4. Correct or not? Right. What is the formula for x power m? Whole power n. X power mn. 4 into 101. 4 into 101 is what? 404. Satisfies? Right. Let us coming to next term. Minus. Here 4C1 is there. So 4C1 into this part can be written as y power how much? 3. 3 into 101. 303. Fine. Let us coming to next one. 4C2 into this part can be written as y square. Okay. Then only 2 into 101. 202. Fine. Minus this one 4C3 into y. Okay. Y or y power 1. 1 into 101. Value 101 only. Plus 4C4 can be written as 4C4 into y power 0. Okay. Y power 0 is 1 1. At the last this minus 1 as it is. Fine. Now you observe this one. Only for this part. Can you guess this value? Right. This expansion is equal to what? See that next slide. Y minus 1 whole power 4. Is it correct or not? If you want, you check it. What is that formula? 4c naught into y power 4. It is there or not? Right. Next, minus, because minus is there, alternate sign. 4c1 into y cube. Is it correct or not? Right. So this expansion is equal to what? Y minus 1 whole power 4. At the last, minus 1 as it is. Now I am substituting y. What is y? Our assumption is what? 1 plus x whole power 101. So 1 plus x whole power 101 minus 1 whole power 4 minus 1. Now expand this bracket. Expansion 101 c naught into 1 power anything is 1 only. Okay, sorry. Fine, nc naught. Next, plus 101 c1 into 1 power 1. Okay, 1 power anything 1 into x power 1 plus 101 c2 x square plus so on 101 c101 x power 101 minus 1 whole power 4 minus 1. Right? 101 c naught value is what? 1 plus 1 minus 1 cancel. But actually calculate what you see here. Given quotient is equal to coefficient of x power 4, right? So in this expansion we want only coefficient of x power 4 is equal to x power 4. Anyhow here power 4 is there. So if you are taking this part, automatically x power 4 we can get. Correct or not? Apart from this, anything if you are taking, we won't get x power 4. So x power 4 coefficient in this expansion is equal to what? 101 c 1 101 c 1 and power how much is there? 4. So that is equal to what? 101 power 4. 101 whole power 4. That is the answer for given question. You see which one is okay. Second option satisfied. 101 power 4. Right. Now let us coming to next one more question. Reminder. One important model. 27 power 999 is divided by 7. Then remainder is dash. Okay. So reminder questions, just you remember one simple trick. Reminder or otherwise units place digit in the number. Suppose some 27 power 999 or otherwise last two digits. Such type of questions are there. Better you convert this base into either 1 plus x or 1 minus x or x minus 1 form. Okay, right. And here for this question, x must be either 7 or multiple of 7 or multiple of 7. Then only we can easily identify that one. Understood? Now base value first you write either in 1 plus x or 1 minus x or x minus 1 form, where x is either 7 or multiple of 7. Then we can easily simplify this one. Understood? Right. So let us coming to this question. Base is what? 27. Now you observe that one. 7 multiple answer nearer to 27. 7 multiple answer nearer to 27. What is that number? 7 ones are 7, 7 twos are 14, 7 threes are 21, 7 fours are 28. 28 is nearer to 27. Correct or not? So 27 power 999 can be written as 28 minus 1 power 999. Now understood or not my point? Okay, right. Why I wrote especially 28 minus 1 only? Understood? Because 28 is multiple of 7. Right? 7 4s are 28. Now expand this one using binomial theorem formula. This can be written as 999 NC naught, 999 C naught into first element, that is 28, first element power difference for 999, okay, into second element 1 power 0, 1 power anything, anyhow 1 on. Symbol minus is there, so alternate signs exist in this expansion. So next term will be minus 999 C1 28 power 999 minus 1 998 and so on. Last term is what? 999 C 999. Before that term 999 C 998 28 power difference is what? 1. And what about this sign? 998 even or odd? Even. So symbol positive. Next minus 999 C 999 28 power 0. Okay. So observe this one up to this part. From starting to here, common term is what? 28 na? Okay, 28 common. Remaining is what? 999 C naught. 28 common. So remaining value will be 998 and so on. Last term is 999 C 998 minus 999 C 999 NCN value is what? 1. So I am writing 1. So complete this box is what? Multiple of 28. Multiple of 28 means it is divisible by 7 or not? Right, it is divisible by 7 because 7 4s are 28. So complete this part is divisible by 7 and remaining excess is what? Minus 1. So remainder is minus 1. Correct? Is it correct? Is it correct? No, because here remainder you are telling remainder minus 1. In general, remainder negative possible? No, not possible. So remainder minus 1 means wrong. Then how to solve this one? Simply 7 minus 1. How much? 6 na? Right. Add and subtract 6. So minus 6 plus 6 I am writing. Okay. Anyhow this part is divisible by 7. Fine. Minus 1 minus 6 minus 7 plus 6. This part is divisible by 7 or not? Right, divisible by 7. Now excess part is what? Plus 6. So therefore remainder is equal to 6. Remainder is equal to 6. Yes, 6 is there or not? Right, it is there. So fourth option correct. Now understood problem? Right. Now let us coming to next one more question. Sigma R range from 0 to n. NCR minus 1 by NCR plus NCR minus 1 is equal to 25 by 24. Then find n. Suppose if you know that procedure, fine. Otherwise, just you go for options verification. First put n is equal to 3. Simplify it. Answer 25 by 24 or not. If it is there, fine. First option correct. Otherwise, verify with 4. Otherwise, 5. These 3 wrong means obviously fourth option only correct. Procedure understood? Okay. Now, I'm not using here options verification process. Now let us go for general procedure only. Fine. Okay. Let us see. I'm taking left hand side part. That is sigma r range from 0 to n ncr minus 1 by ncr plus ncr minus 1. Okay. Now let us see simplification. This numerator value I am writing in denominator. Then automatically sigma 1 by splitting ncr by ncr minus 1 plus ncr minus 1 by ncr minus 1. Is it correct or not? Right. Here this cancel. Understood? Let us see next slide. Sigma 1 by remaining is what? ncr by ncr minus 1 plus 1. Here sigma r value starts with what? 0, ends with n. Right. Now here simplify this one using ncr formula, and then few terms will be cancelled and then you find out. Or one simple trick you see here. This can be written as sigma r range from 0 to n 1 by this plus 1 as it is I am writing. This part simplification, just you see one simple approach. In numerator and denominator, you observe this one, upper suffix is same, right? And lower suffix difference how much? 1. And numerator lower suffix is highest value. Correct or not? So at that time, this simple approach, you write like this, upper suffix minus denominator lower suffix by numerator lower suffix. That's all. Understood? When will we write this one? Upper suffixes is same, lower suffix difference is 1, and in numerator it contains highest value. That time you follow this simple approach. Right? Upper suffix minus denominator lower suffix by numerator lower suffix. Clear? Okay. After that, general simplification, find LCM. Sigma r is equal to 0 to n. Okay. 1 by LCM is what? R. Numerator n minus r, minus into minus plus 1 plus r. So anyhow here r cancel, fraction reverse. So that is equal to sigma r range from 0 to n r by n plus 1. R by n plus 1. Correct or not, you see? Okay. So here actually printing mistake, power 3. Okay. So anyhow, hold this power 3. This part also power 3. So then here also power 3. And here also power 3. Here also power 3. And here also power 3. So that is equal to, so n plus 1 separately I am writing into remaining is sigma r cube. R value starts with 0, ends with n. Okay, sigma of R cube, that is sum of cubes of first n natural numbers. That formula will be what? 1 by n plus 1 whole cube. Formula is n square into n plus 1 whole square by 4. So here simplification, n plus 1 whole square, here n plus 1 whole cube, 2 times cancel. Then remaining value will be what? N square by 4 times n plus 1. Correct or not? Right. So you observe that one, that is equal to 25 by 24. Fine. N square by 4 times n plus 1 is equal to what? 25 by how much? 20. Just you see here, 24. Fine. Cancellation possible. 4 ones are 4 6. Right. Here no need to do like this cross multiplication, then quadratic roots. No need. Just by observation only. If you are taking n is equal to 5, equation satisfies or not, cross check it. N square, 5 square, 25, 5 plus 1, 6. Satisfies or not? Right, satisfies. So, which option correct? Third option correct. Clear? Right. Let us coming to next one more question. Here some expansion is given like this. 3 plus x power 2008 plus x power 2009 whole power 2010 is equal to a0 plus a1x plus a2x square plus so on an x power n. Then find this value. Okay. Now, any idea about this one? Just by substitution method, we can easily find out. Substitute what? See, first 3 terms, second 3 terms, almost same format is there. Right? 3 terms are there in same format. At that time, you go for cube roots of unity you take. Okay, that is cube roots of unity 1 omega square. Fine. So, substitution, first you put x is equal to omega. Before solving this question, cube roots of unity formulas I am writing. What is the formula for 1 plus omega square is equal to 0? Omega cube value is what? 1. Omega is cube root of unity. Fine. Okay. Let us see here. I am writing this question this side. 3 plus x power 2008 plus x power 2009 whole power, something is there, whole power how much? 2010. Fine. Is equal to what? a0 plus a1x plus a2x square plus a3x cube plus a4x power 4 a power 5x power 5 plus a6x power 6 so on, and then last an x power n. Fine, anyhow you leave it, an x power n. So what I told, substitution, put x is equal to omega. Then what will happen, you see, 3 plus omega power 2008 plus omega power 2009 whole power 2010. Okay. So that is equal to what? Right side also you substitute. Fine. Right side a0 plus a1 omega plus a2 omega square plus a3 omega cube plus a4 omega power 4 plus a5 omega power 5 plus so on an omega power n. Okay. Next to put x is equal to omega square. Put x is equal to omega. We got here. Next you put x is equal to omega square. Then it becomes like this. 3 plus omega square whole power 2008. Next omega square whole power 2009 whole power 2010. Okay, so that is equal to what here? A naught plus a1 omega square, a2 omega power 4, a3 omega power 2 3s are 6 plus a4 omega power 2 4s are 8. Correct or not? Okay, so next term will be a5 omega power 2 5s are 10 and so on. Last term, even though if you are not writing also no problem. Right. After that, add these two equations. Addition. Okay. And see here simplification. Omega power 2008 and omega power 2009. Values I am calculating separately. Here I am writing using omega power 2008. Value can be written as using these two formulas only I am calculating. Fine. So omega cube 1. So omega power 3, how many times you check it? 3 6 18. 20 minus 18 2. 2 0 20. So 3 6 18. Correct na? 2 8 28. 28. 3 9s are 21. So 27. Remainder 1. So plus 1. So this can be written as omega power 3 into 669 into omega. Here I am using formula x power m into x power n is equal to x power m plus n. Fine. So omega cube value is what? 1. 1 power anything is 1. That is equal to omega. Right. What about omega power 2009 value? This can be written as omega into omega power 2008. So that is equal to omega into this value omega. So that is omega square. Sorry, omega. Omega into omega, omega square. Fine. Next, I am calculating one more value. Omega square whole power 2008. That is equal to omega power 2008 whole square only na. Correct or not? But omega power 2008 is what? Omega. So omega square. Similarly, omega square whole power 2009 can be written as omega power 2009 whole square. Is it correct or not? But this value is what? Omega square. Omega square whole square. Omega power 4. Omega power 4 can be written as omega cube into omega. That is equal to what? Omega. Fine. These four values I am substituting in this equation you see. So add these two equations. So at a time I am writing 3 plus. What about omega power 2008? Omega power 2008 is omega we got. Fine. So omega and this value omega square whole power 2010 plus addition I told. So this value also 3 plus. What about this value? Omega square. Plus what about this value? Omega. whole power 2010 is equal to, right side part I am writing. Now you see a naught plus a naught, value is what? 2 times a naught. Next add these two, in these two common term a1, so plus a1, remaining is omega plus omega square, and in these two common term is a2, a2 common, remaining omega square plus omega power 4. Fine. In these two common term a3, a3 common, omega cube plus omega power 6. In these two common term a4, a4, remaining omega power 4 plus omega power 8. Okay, a5 common, omega power 5 plus omega power 10 plus so on, last term. Fine. Now let us see here simplification. What about this value omega plus omega square? You see here I wrote omega plus omega square, value will be what? Plus 1, shift that side, minus 1. So minus 1, 3 minus 1, 2. So directly I am writing 2 power 2010 plus, here also what? Same only, 2 power 2010. Okay, so that is equal to what here? That is equal to, right side you see 2 times a naught, 2 times a naught. Okay, next coming to this one, omega plus omega square, value is what? Minus 1. So minus 1. Here omega power 4 means what? Omega only. Omega plus omega square minus 1. Minus 1 into a2, minus a2. Okay. Similarly, here omega cube 1. 6 is 3 multiple only. So this value also 1. 1 plus 1, 2. So 2a3. Okay. Then next, this part if you are taking this one, omega power 4 means what? Omega. Omega power 8 can be written as omega power 4 whole square. That is omega square. But omega plus omega square minus 1. So minus a4. Same way this value minus a5 and so on. Fine. Here 2 power 2010 plus 2 power 2010. It is just like x plus x. X plus x is what? 2x. Okay. After that, dividing both sides with 2, then 2x, 2 cancel. Correct or not? So answer will be 2 power 2010 is equal to, divide with 2 I told. So a naught minus a1 by 2 minus a2 by 2 plus a3 minus a4 by 2 minus a5 by 2 and so on. Now you check it, right hand side part and question same or not? Right, same. So answer is what? 2 power, how much we got? 2 power 2010. 2 power 2010. So first option correct. Understood? Right. So in next session I will explain with some other topic. Thank you.